Welcome to The Explainer. I was looking into this completely fascinating intersection recently, the exact point where cutting-edge robotics, musical artistry, and human psychology all just kind of collide. We've all seen machines do incredible, lightning-fast tasks, right? But music is deeply human. It's about feeling, emotion, connection. So what actually happens when we try to teach a machine, not just to rigidly play notes, but to actually feel the groove with us?
So let's just dive right into it. Playing fast? That is literally child's play for a computer. But can a robot actually jam with a human being? Think about your absolute favorite live band. When they're totally in the zone, they aren't just reading sheet music, they're communicating, they're locking in together. It makes you wonder, are machines forever doomed to just execute code like a giant human metronome? Or can they truly synchronize with our inherent human unpredictability?
It's kind of funny, if we look back at the early 2010s, the goal wasn't collaboration at all. We saw the rise of what you could call the robot rock spectacle. Engineers were building these machines primarily for superhuman speed and absolute rigid precision. The whole point was sheer, jaw-dropping novelty. It was really just about showing off what pneumatics and servos could do when you push them to their absolute physical limits.
Take, for example, a couple of wild projects from that era. Back in 2014, the electronic artist Squarepusher collaborated with a Japanese robotic team to create an EP called Music for Robots. They used the Z Machines, this robotic band featuring a guitarist with a mind-blowing 78 fingers. Because, apparently 10 just wasn't cutting it for heavy metal. Then jump to 2017, musician Nigel Stanford released Automatica. He programmed massive, heavy-duty KUKA industrial robots to flawlessly play the drums, piano, and bass right before they spectacularly smashed their instruments to pieces at the end. These spectacles proved beyond a shadow of a doubt that machines had totally mastered the physical mechanics of playing music. But here is the catch. Those early musical robots were entirely efficiency-driven. Just like in an automotive factory, industrial arms are designed to minimize unnecessary movement to save time and energy. But human musicians don't play like that at all. We sway, we nod, we breathe. We are highly gesture-aware. For a robot to actually collaborate with us in a meaningful way, it needs to step away from pure efficiency and start communicating intent through body language. The researchers at Georgia Tech really hit the nail on the head when they noted that this efficiency-driven approach just cannot convey rich, expressive information to the robot's musical collaborators. Think about it. If a machine sits perfectly, terrifyingly still until the exact millisecond it needs to strike a key, it leaves the human musician completely in the dark. There's zero anticipation. There's no shared breath. It's just cold. So to fix this massive communication gap, the researchers realized they had to teach a robot how to essentially speak musician. And they did this by breaking musical movement down into 3 really simple, distinct categories. Let's walk through these to understand how musicians actually communicate with each other on stage. First up, we have instrumental gestures. These are the absolute baseline mechanics. It's basically any movement directly related to creating the sound itself. Plucking a guitar string, pressing a piano key, hitting a snare drum. If a robot only does this, well, it's just a fancy player piano. It makes sound, sure, but it isn't communicating a thing. Second, we have ancillary gestures. Now, these are the physical flourishes that color the sound. Think of a pianist dramatically lifting their arm high into the air before bringing it down for a heavy chord, or a trumpet player taking a massive, highly visible breath right before a solo. These movements aren't making the sound themselves, but they accompany the action, and they give everybody else in the room a huge visual heads up about what is about to happen next. And finally, we have social gestures. These are purely communicative movements. They don't affect the sound in any way whatsoever. It's the drummer making intense eye contact with the bassist. It's the lead singer bobbing their head to set the tempo for the band. These nonverbal cues are absolutely crucial for humans to lock in and synchronize. Without them, a band just completely falls apart. We've all sat through those awkwardly disjointed high school talent show performances, right? Okay, so this is where things get incredibly cool. Meet Shimon. Shimon is a robotic marimba player developed at Georgia Tech's Robotic Musicianship Lab. And here is the kicker. Shimon wasn't built just to play crazy fast. Shimon was built specifically to test if machines could use these ancillary and social gestures to actually collaborate with human beings in real time. To actually pull this off, the engineering team had to give Shimon 2 completely distinct mechanical systems. The system is essentially split right down the middle.
The bottom half controls the arms and the mallets, using these high-speed motors for dynamic instrumental and ancillary gestures. But the top half, that's where the magic happens. It controls Shimon's head and neck using a complex 6-degree of freedom system designed entirely for social cues. Because Shimon doesn't technically need its head to play the marimba, that head is 100% dedicated to communicating directly with you.
So they programmed Shimon to mimic human behavior using that head and neck. At a constant tempo, Shimon will literally bob its head to the beat, exactly like a human player feeling the groove. But even more importantly, when a musical shift is coming up, Shimon pans its neck to look directly at the human player and tilts its head up or down to signal an upcoming change in speed. It's essentially giving you physical visual cues. To see if this actually worked in practice, they set up an experiment. They brought in 13 human pianists and tasked them with playing this exact piece of sheet music. It's a Taiwanese folk song called Pining for the Spring Breeze. The humans were in charge of the melody, and Shimon the robot provided the accompaniment. But of course, there was a catch. The humans had to follow Shimon's lead, and Shimon was explicitly programmed to surprise them with totally unexpected tempo changes. The test mapped out these crazy tempo curves. Sometimes Shimon would play perfectly steady at 110 beats per minute, but then, completely out of nowhere, the robot would suddenly speed up or dramatically slow down, forcing the human to scramble, react, and try to stay perfectly in sync. Now, these unexpected curveballs came in two very difficult flavors. First, you had slopes. This is where the tempo would gradually accelerate or decelerate by 20 beats per minute over the course of a full measure. Tricky, but manageable. Second, you had leaps, which are just brutal for a live musician. A leap is an instantaneous, sudden jump or drop of 20 beats per minute with absolutely zero warning written in the sheet music. Literally, the only warning the human player had was Shimon's body language. Before we get into how the humans handled these surprises, let's establish a quick baseline. When Shimon played at a nice, constant, predictable tempo, the human pianists were off by an average of just 34 milliseconds. That is a microscopic deviation. It basically proves that when things are predictable, we humans have absolutely no problem locking in and playing flawlessly alongside a machine. But what happens when the tempo unexpectedly shifts? Well, here is the big reveal. When the tempo unexpectedly changed, and Shimon gave zero gestures, meaning it just played the notes completely stiff and still, the humans really struggled. They lagged behind significantly. But when you look at the results of combining Shimon's arm movements with its head bobbing and eye contact, the human's playing delay just plummeted. Those visual cues practically bridged the entire gap, allowing the human musicians to stay tightly locked in with the machine, even during those brutal surprise tempo changes. So what is the big takeaway here? Why does this matter? Because they actually achieved true synergy. The data proved beyond a doubt that arm and head gestures significantly enhanced synchronization. By reading the robot's body language, humans could actually anticipate the music rather than just frantically reacting to a sound that had already happened. And honestly, maybe the best part? The subjective surveys from the pianists showed they felt so much more positive and engaged when interacting with a robot that physically moved like a real musician. It totally bridged the gap from a programmed novelty act to a genuine musical collaborator.
Which leaves us with this final, honestly, pretty wild question to ponder. We have gone from robots that play with 78 fingers purely for spectacle to machines that intentionally bob their heads and make eye contact to build trust and synchronization. If robots are now mastering our subtle body language to seamlessly jam with us in something as deeply emotionally human as music, what other human-machine interactions in our daily lives are about to completely change? Thanks so much for joining me on this explainer, and definitely keep your eyes open for the future.